Hello Year 5 and welcome to your last maths lesson for the week. So, I'm sorry, I got completely put off then on the basis that when I was in school the other day, Keaton and all the other children at school, so Keaton and Deborah and Megan, all laughed at me because I introduced my lesson going, "Good morning Year 5, how are you?" And I'm going to have to make a real conscious effort to not do that when we come back and have a look at our lessons when we come back to school. My goodness. Anyway, off topic. So, we're going to be looking at adding fractions today, okay? Now, it gets a little bit more complicated towards the end of the lesson, purely because some of the fraction work that we're going to be looking at, there could be multiple different answers. So it's more a case of you need to understand the technique of how to work out the correct answers, rather than only being able to focus on one answer. So I'll usually give you an example, but there could be multiple different answers, okay? So because I want to try and explain that to you today, we're not going to do our warm-up of our multiplication and our division, but we are going to do the warm-up of our fractions, okay? So what you need to do here is you need to see if you can work out the missing fractions that are going to be in our part whole here and the missing numbers that we're going to have here on our fractions, okay? So you may need to go back and you may need to check that the denominators are all the same and how we would make them bigger to work out what that original number was, okay? But you need to have a go at doing that. So set yourself a 5-minute timer. Don't worry if it takes you a little bit longer than 5 minutes because you are going to have to convert all of these fractions to be able to find out what that one is, okay? But I should just pause the video and have a go. Okay, so if we look at the first one, okay, we'd have 1 1/4. Now we didn't have to convert any of them in here, okay? So I might have tricked you a little bit. If I add 2 halves together, 2 halves added together gives me a whole, and then I'm left with 1/4. Same for these ones here. I could have exchanged these fractions, okay, because I've got my sevenths here, which go into my 21. Equally though, I've got 2 denominators here with the same number, okay, so I could potentially have then added them together, okay. But in this instance, unlike this one, I can't do that, so I've had to exchange these both for the 21s. So when I then exchange them, okay, so this would have been 9 and this would have been 15. If I add 15, 9 and 4 together, that's going to give me 28. Now this one here, how do we get from 5 to 15 and multiply by 3? So 1 times 3 is 3. When it happens, then I think, well, how do we get from 3 to 9? Multiply by 3. So we get to 15 multiplied by 3. It's going to give me 45. Okay, so those are all equivalent fractions. So you know when I showed you the multiplication grid the other day and I showed you that trick of how they work? 1/5 is the same as 3/15, which is also the same as 9/45. So these are all 1/5. So that's the number we would simplify it. So when I talk about simplifying a number, if I gave you 9/45, we'd simplify that. So we'd potentially divide it by 3, and that would give us our 3/15, or potentially give us our 1/5, okay? Or the reason it would give us the 1/5 is because we know that 9 goes into 45 5 times, so it's 1/5, okay? So those are all equivalent fractions to a fifth, okay? So let's confuse your brains a little bit more today because I'm going to be evil Miss Humphrey. So this one is not evil though. This is easy peasy. Okay, 5, 6 add 2/3. You can already see our denominators are different, but they're both multiples of the 6 times tables. Okay, or factors of 6. So all we need to do is we need to convert this one so the denominator is 6. So, okay, so it's going to give us 4/6. Okay, so here I've got 5, 6. Now I need to add 4. So I'm going to add 1. Okay, and that gives us a whole. Now I can't add that second one on the end because now I've got sevenths. Okay, so we need to exchange that over. We need to start a new whole line. So if I then add on those 4 I've got there, if I count them all together, I've got 9/6. Now, what type of fraction is 9/6? Good, it's an improper fraction. So what could I do to change it from an improper fraction? I could turn it into a mixed number. So, as we've done before, how many 6's are in 9? So just going to divide it. How many 6's can I get into 9? I can only get 1. Okay, how many would I then have left over? 1, 2, 3. Now, do you think I can simplify to make that fraction smaller? So let's think about the rule that I explained in our video yesterday. We're going to simplify, start with the smallest divisible number and work your way up. So we're always going to start with 2. Okay, because we can't always divide by 1 because that's still going to give us 3/6. So let's start with 2. Are both my denominator and numerators divisible by 2? No, they're not. Okay, because we've got 3. So we can't divide it by 2. So let's see, can we divide it by 3? So we're going to work our way up. Well, yes, we can divide it by 3 because both these numbers are multiples of the 3 times tables. So how many 3's are in 3? 1. How many 3's are in 6? 2. So it's the same as a half. Okay? Easy peasy. Easy peasy. So let's have a look at this one. It's got 3/4 add 1/2 add 7/8. Okay, so I'm going to focus on my 8. So I'm going to convert all of my fractions to the denominators are 8. Okay, to get from 4 to 2, multiplied by 2. 2 to 8 is multiplied by 4. Okay, remember whatever we do to either our numerator or denominators, we do to the other ones as well. Now we can see from our number bonds here, 6 add 4 is 10. Add the 7 is going to give us 17/8. Okay. Now, that again is an improper fraction. So let's see if we can convert it. So same as always, we're going to do 17 divided by 8. So how many 8s are in 17? So we've got 8, 16, and we can't go any further. So we've got 2 whole lots of 8, okay? And then we need to think, well, how many have left over? So from 16 to 17, it's going to give us the 1/8, okay? Same as you can see here, we've added it with our 2 whole bars and our 1 left over. So now that I've shown you how to do that, I want you to pause the video and have a go at these ones. So you can have a go at filling in the gaps if you want to draw them. Equally, you can just convert your fractions and write the answers. If you have a number that you think you can simplify, please simplify the answer. So pause the video and have a go. Okay, so the common denominators here I can have is 18. Okay, 9 goes into 18 twice. So we can do our 10 and our 11, okay, is going to give us our 21/18, and we can divide that, okay, and turn it into a mixed number. 18 goes into 21 once with a remainder of 3, so it'll be 3/18. Now I'm looking at 3/18 thinking that looks familiar. Well, let's try and divide it by 2. Well, I can't divide it by 2 because 3 is not a multiple of 2. So can I divide it by 3? Yeah, I can. Okay, 3 and 18 are both multiples of 3. So 3 goes into 3 once. 18 goes into 3 6 times. So we've got 1/6. I had to think there. My goodness, come on, Miss Humphrey, wake up. So 1 and 1/6. So 1 whole and 1/6. Okay. Let's have a go at this one. We've got 12, 24, and 6. Okay, we can actually bring this one down, okay, and switch them so that they are 12. Okay. Now, equally, we could have moved them up to 24. Okay, so we could have doubled this one, kept 24, and 6 could have gone up. But equally, we could have made it smaller because these are both even numbers and both then divisible by 2. Okay, so we've moved it down. So here we actually made the fraction smaller. Okay, and here we made the fraction bigger. So now what we need to do is add the 10, 11, and the 5 together, and that's going to give us 26. So now we need to think, well, how many 12s are in 26? So we've got 12, 24. We can't go any further, so we've got 2 wholes. And then we've got 2/12 left over. Now I'm instantly thinking to myself, is 2 12s divisible by 2? Yeah, they are. They're both multiples in the 2 times tables. So 2 goes into 2 once, and 2 goes into 12 6 times. So that's 2 and 1/6. Okay? Easy peasy so far? Okay, well then let's prove it then. Have a go at doing questions 1 to 3 on your worksheet for me. Off you go. Okay, right. This is where we take a deep breath. Okay, because I could potentially about to blow some of your minds. Now, I know I might make it sound like it's going to be complicated, but it's not as complicated as it looks as long as you take it step by step. Okay, so take this very slowly, okay, so that you know what to do. Okay, each piece of information though will be repeated, so don't worry, I'm not going to expect you to remember everything I'm about to flash up on the slides to you. So Eva has some bottles of lemonade, water, and apple juice. Okay. Now the bottles have a mass of 3 kilograms all together. So the bottles of lemonade, water, and apple juice all together weigh 3 kilograms. Okay. So the water bottles have a mass of 7/8 of a kilogram in total. So depending on how many bottles there are, in total they all equal 7/8 of a kilogram. The lemonade bottles have a mass of 11/16, and Eva has 2 of them. So she's got 2 lots of 11/16. We need to find out how much the bottles of apple juice weigh. Okay, so just want you to pause the video and have a think. How could I record this information using a bar model that's going to help me identify that missing weight for the apple juice? Just pause the video and just have a think if you might know. Well, let me show you. Okay, so we have our lemonade, water, and apple juice. Okay, we know that all together they equal 3 kilograms. Now you've seen me do this before. Okay, I can't remember what this is called. It's a bit like a cleft, but we add the 3 kilograms. So all 3 of these added together give us 3 kilograms. So let's start off looking at our water. So our bottles of water have a mass of 7/8 of a kilogram. Now it doesn't tell us how many bottles, but we don't need to know how many bottles because we know what the total of them all together would be. So let's represent that as a bar, and we're going to write our 7/8 of a kilogram. Let's have a look at our lemonade that Eva has. So Eva has two bottles of lemonade. And each bottle is 11 kilograms. So each bottle is 11 out of 16 kilograms. So there's the first bottle, and that's 11/16. She has two bottles, and that's also 11/16. Okay. Now, in order for me to find out this missing one here, what do you think I might need to do? Okay, so I need to find out how much the lemonade and the water bottles weigh all together. But has anyone spotted what my problem might be, adding those weights together? My denominators don't match. Yes, my numerators match for this one. Okay, but my 7s, I'd be going all the way up to 77 if I tried to exchange them. So I need to make my denominators the same. Now I can see a comparison of 8 to 16. 8 goes into 16 twice. So I can multiply 8 and 7 by 2. Okay, and exchange that to 14/16. So now I've got three numbers that I could potentially add all together, okay, to give me that answer. However, once I've added those together, I've got to take them away from the kilograms. What's this number here? Because that doesn't look like a fraction to me. What is that number? That's a whole number. So how am I going to turn that whole number into a fraction? Good. I need to work out how many 16ths there are in that 3 kilograms. Okay. So I need to convert this now. So I need to work out how many 16ths I can get into 3 kilograms. So I've got 16/16, that's 1 whole. Then I'd have 13/16, that's 2 wholes. Then I'd have 48/16, that's going to give me 3 wholes. Now I know it's got to be lots of 16 because my denominators are 16. So my 3 kilograms here is actually 48/16. So now I have all of my fractions, all with the matching denominators. So now I can do what you just told me a minute ago. If I add these all together, I can then find out the difference. Okay, so let's add them all together. So we've got 11 and 11. Okay, that gives us 22. Add the 24 gives us 36. Okay, now all together it's 48, including the apple juice. And I only know the weight of all of these ones. So how am I going to work out the difference between the lemonade and the water and the apple juice? I could take it away from the biggest number. So I've got 48. If I take away the 36, so if I take away the lemonade and the water, that's going to tell me the weight of the apple juice at the end. Okay, so 48 take away 36 is 12/16. Okay, now that may have looked a lot more complicated at the beginning, but if we break it down and you know your knowledge of matching your denominators or matching your numerators, it's easy. And as long as you've always got all fractions or all whole numbers or all mixed numbers or all improper fractions, it works. Okay, so I'm now going to add a spanner in the works. Now I'm actually going to tell you this. Eva actually has 3 bottles of apple juice. So altogether, just like the water, altogether they had 14/16 kilograms, which we didn't need to know how many bottles. Now all of the apple juice bottles together are 12/16, so there's 3 of them. So how am I going to work out what one bottle is? Thinking about if I've now got to make that smaller, what do I do when I'm making a number smaller if I'm sharing it between the 3 bottles? Divide it by 3. Now I only need to divide the numerator because obviously my denominator is going to stay the same because that's how many equal parts each of them weigh. But I need to divide my numerator by 3 because that's going to tell me how much each bottle is. And 12 divided by 3, okay, is 4/16. So each bottle is 4. So I should have 4 together, 4, 8, 12. That's going to give me 12/16. Now my only question here to you now before I let you go, can I do something with 4/16? Yeah, I can simplify it. I can simplify it by dividing it by 2. Okay, when I divide that by 2, it gives me a quarter. Okay, so each one of those bottles together weighs a quarter of the original size that they are. Okay, well done if you managed to keep up with that one. If you feel like you need to go back and watch it again, go for it. But all you need to remember, you need to match your denominators. If you've got a big whole number here, you need to work out how many whole parts there are to turn it into a fraction. And then it's your simple multiplication facts and division facts that we know. Add them all together and take them away from the biggest number, and that's going to give you the difference.